Okay, let's talk about nuclear reactors. Basically, the basic structure of a nuclear reactor is we have to have a nuclear reactor next to a water source to keep as a to fill the condenser in order to go from steam back to water. So water is being used at 27 degrees from your river or from your ocean. Once it's been warmed, we put it back into our river or ocean at 38 degrees Celsius, or approximately about that temperature. In this container, we have steam coming in. It condenses, becomes water, gets pumped in here, and this is basically called the heat exchanger. The water here is then warmed up by this water that's in contact with our nuclear fuel. When this actually water boils and becomes steam, it gets piped over, goes into the turbine, which then is spun by the steam, and then it forms an electric generator, and this is how we get our power. In this region here, in the actual nuclear reactor with a heat exchanger, we have basically a closed system here. Water is used as a primary coolant and a moderator. And what a moderator does is when we have a nuclear reaction or basically radioactivity, the neutrons can actually be expelled at a high velocity. And if it's too high of a velocity, then it becomes uncontrolled. So water acting as a moderator helps to slow down the neutrons in order to keep them more controllable. So we have basically uranium-235 fuel cells, and then from there we have what we call control rods. And the control rods basically is either boron-10 or it's an alloy of silver, indium, and cadmium. And what they do is they actually absorb excess neutrons. So we actually can manipulate these control rods by lifting them up and removing some from the reaction or putting them down. And by absorbing our neutrons, we can control and maintain this critical mass so that we don't actually have any supercritical reaction occurring. And so this water, this moderator water, gets piped in and pumped through this whole system here. And because of the heat exchanger, that's what gets it cool. So when we had something like a nuclear plant meltdown, what happened is with all of these coolants, basically there was a problem with that. There could be basically, as the materials, the reactors get old, there could be the materials are no longer, they can form cracks, and so it can no longer hold the radioactive material inside. When we had basically the tidal wave, okay, basically what would happen is that force caused cracks, and so some of this radioactive water spilled out into our water source, like the ocean, and that's why we ended up getting some radioactivity in the ocean when we had the tsunami. So that's our nuclear reactor, and our next section will be on fusion and biological activity.